come to the ceramics. What are the ceramics? This is also other kind of materials. Okay, so materials can be categorized, very different or very and too many in a very different way, right? So sometimes it depends, I mean, on what basis you are defining, you are categorizing your materials. Okay, if it categorize on the basis of uh, the atoms present, then this is a metal and non-metal. If we talk about the how they behave when they if we pass the electricity through them, then we have the material like the conductor or non-conductor. Okay, so similarly we have the different uh, materials on the basis of their hardness, their kind of the brittleness, their melting point. Okay, melting point means the point at which if you raise the temperature of the material, okay, when they reach at that particular temperature, they will start melting. Okay, so that is another melting point. So on that basis, you have other different kind of materials like the ceramics. Okay, uh, uh, and the different kinds of the materials as well. So if we talk about metal, non-metal as well. Okay, so if we talk about the ceramics are broad class of the materials that are typically non-metallic. Okay, so in non-metallic, I mean, you have a category of metal and non-metal. In non-metal, you have other category of ceramics, and in inorganic. I mean, if we talk about the material categories, then you have other organic, inorganic. Organic means the material which have the carbon component. If they have not a carbon component, then it is known as the inorganic. Okay, so if we talk about the ceramics is a kind of the non-metallic. Okay, I mean it means they are non-metal. Okay, and non-metal it means they cannot conduct the electricity as well, because most of the non-metals are non-conductor of electricity. Okay, so non-metal, what there is, the inorganic means they don't contain the carbon compositions. Okay, so if the chemical formula they have carbon component, then it is known as the organic, otherwise it's known as inorganic. Okay, and just having the one molecules of carbon is not sufficient, but the carbon and hydrogen is the main component in a material that is known as the organic. Organic means the carbon and oxygens or hydrogen as main component, then it is the organic. The rest all are known as inorganic. So it is kind of the things, ceramics are the kind of the things which is non-metal. Okay, and are inorganic and often crystalline in structures, as you can see. I mean, at the beginning, you have to decide. I mean, what the kind of the material. Material have the kind, two kinds. First is crystalline, and second one is the amorphous. What is the basis? The defining these two materials. The basis is the on the behavior of the atomic arrangement at the atomic level. So on the basis of the atomic arrangement at atomic level, you have the two kinds of materials basically, solid materials we are talking about. Okay, so crystalline or amorphous. So ceramics are not amorphous; it's a crystalline materials. So you can think about crystalline, non-metal, and inorganic. Okay, so whenever you listen the word ceramics, it means they are non-metallic, inorganic, and crystalline. So you think about if it is a crystalline, then you need to know what the kind of the unit cell they contain, what the kind of the crystal structures they are. So these are the things you need to define. You need to know about that. Okay, if the ceramics, because if ceramics are not the kind of the amorphous, if this material which are amorphous, you don't need to know about the crystal structure or unit cell of that. Okay, so they are widely used for their unique properties, okay, which includes the hardness, as I have already told you, hardness, high melting point, and chemical stability. So chemical stability is more important when we talk about other chemical or the material science, because stability across all the world. Okay, stability is important basically. Without stability, everything in this world wants to be stable. If we talk about the human beings or or anything you can think about, if everything in this world want to be stable. Okay, so stability is more important, and stability of many kinds. So chemical stability, what I mean, I have already told you that, I mean, everything in this world is tend to be a less energy, having the less energy. Why? Because the less energy have a tendency to be stable. So this is a direct relation. Okay. So stability is important, but stability comes due to the less energy. If the something which has the high energy, they cannot have the stability. So stability comes under the less energy. That's why everybody, everything, every material in this world try to tense their energy lower. Okay, so that they could have the stability. Okay, so stability comes from the less energy. So energy must be less to of any materials. If suppose the material is present in their own way, in a natural form, they are definitely in a less energy or in a stable form. When we modify, we apply the engineering things over the material, then we change the stability. That's why they try to come down to their the natural or their lower energy. As we have seen, if something is keeping it somewhere else. Okay, you have like just the pendulum. Okay, so pendulum is just you know in a standby mode. There is no kind of the unbalanced forces over there. They are at a very rest position. Once you disturb the pendulum, how they behave, they try to come up and down, and at the rest they come to the neutral position. Why? Because it was at the beginning on the in the stable position. So stability is the fundamental desire of every materials. Okay, so stability comes under the energy, under the less energy. Okay, so less energy, how they will come? Either you, once you have disturbed the pendulum, it means you have given the energy. You- How you have touches the material and you have kept at the top. It means you have given what the kind of the energy that you have given the mechanical energy. You by yourself have moved the pendulum, right? So you have transferred the mechanical energy into the potential energy. Now the potential energy will convert to the kinetic energy by coming down. Okay, and that kinetic energy will less down by the air molecules. Their collision with the pendulum, the air molecules surrounding to that pendulum, they will resist their movement. So movement will be restricted by the air particles. So there will be as a kind of a friction, and that friction will reduce their motion, and at the end the pendulum will come to the rest. It means the mechanical energy that you have provided to by yourself to the pendulum at the it means what the conversion, you have converted your mechanical energy into the potential energy, that potential energy converted into the kinetic energy, that kinetic energy converted into the due to the friction, they have converted into friction energy, and that friction energy sometimes comes into the sound energy. Okay, so this is the kind of forms of the energy always you know moving in a periodic way. Okay, in a cyclic way. So just a conversion is happening again and again, because the first law of thermodynamics say you cannot create a energy, neither you can create nor destroy, right? So this is the fundamental concept of energy. That's why so how you can look how they behave, how the conversion is basically happening. Okay, so I have moved far away from the topic. So stability basically comes from the less energy. Okay, I have just given an example so that you can have idea how the less energy is required to be stability. Okay, so at the steady position, the pendulum was at a good position. It means they have the less energy. Less energy means it's not about something. Whatever the energy required to be stable, it depends on the material and positions. Okay, if something is a very weird position, they could you have the very less energy required. But if something is very stable or the very like a good way, then they could have the high energy, but still they are less as compared to the others. Okay, so it depends on the position the material has been written, and material has been kept, and the environment and the condition, they all are basically associated with stabilities. Okay. Similar to that, if you have a, suppose the same pendulum, if you would keep in the water, inside the water, what would happen? The same amount of energy you will provide at the beginning of the pendulum. You keep in that pendulum at the on rest. Okay, you provide some kind of the potential energy by yourself, then they will come down to the rest very soon. How? Because they are the water molecules which resist the movement. Okay, so there is the less energy required to be the stability. So it's because the environment, the condition in which the system is kept, that also depends on their stability. So stability is a very broad term that we need to know. So this is the common example, a very frequent example that I have given to you, so that you could have idea how the the stability comes into the pictures.